Hey everyone, welcome back. In today's video, we're going to solve a real business optimization problem using Python. We're going to figure out how many speakers a store should produce each week to maximize revenue. And we'll solve it using linear programming with SciPy. If you've never used SciPy's linprog before, I'll walk you through the entire process step by step, and by the end, you'll be able to solve your own optimization problems. So before we jump into the code, let's break down the scenario. So in the problem, Giselle manages a store that sells speakers. Each thumper takes 4 hours to create the plastic pieces, 2 hours to create the electronics, and 13 hours of labor to assemble the final product. Each XL2000 requires 2 hours to create the plastic pieces, 4 hours to create the electronics, and 10 hours of labor to assemble the final product. The factory has 320 hours to create the plastic pieces, 380 hours to create the electronics, and 1110 hours of labor to assemble the final product each week. If each thumper generates $13 in revenue, and each XL2000 generates $19, how many of each of the speakers should Giselle have the store sell each week to maximize revenue? So there's three things that we need to find: the number of thumper speakers to sell, the number of XL2000 speakers to sell, and the maximum revenue. So our job is to figure out how many of each speaker the store should make to maximize revenue. So let's first import the necessary packages from Python. So we'll import numpy as np, and then from scipy.optimize import linprog. So since we want to maximize the revenue function can be described as revenue is equal to 13t plus 19x. T represents the number of thumpers, and x represents XL2000. So from the problem, it's stated that thumpers generate $13 in revenue, and each XL2000 generates $19. But SciPy minimized it by default, so we multiply the objective by -1. So we create a variable called c, and this is going to be our objective function, np.array. So we write negative instead of positive because by default it minimizes. Now we need to build a matrix of resource constraints, and each row represents one constraint. So from the problem, we recognize that the constraint for plastic would be 4t plus 2x is less than or equal to 320. From electronics, we know that 2t plus 4x is less than or equal to 380. And then we know from the labor equation, 13t plus 10x is less than or equal to 1110. So now we create the matrix. A is equal to np.array So 4 and 2, plastic, 2 and 4, electronics, 13 and 10, labor. Now we create our second matrix, B, which are going to be our constant values. We also require that we can't build negative speakers, so both t and x must be greater than or equal to 0. So that means our bounds is equal to 0 and none. Left side 0 and then right side none. So now let's run the linear programming solver. So we put in C, our main objective function. And we're putting all our parameters in here. So our matrix A, matrix B, and then our bounds. And here we should be able to run the solver. So here, we just changed the way that it's transcribed here, but is 2e to the 1, so it'd be 2 times 10, 8.5 times 10. So this is actually 85, and this is 20. So we know that the thumper there should be 20, and then there should be 85 XL2000 speakers, and the maximum revenue, since this defaults to minimize, negative 1875, it's actually going to be positive 1875. So the negative sign in the objective function is expected, but the true maximum revenue is going to be 1875. So the answers are going to be 20 thumpers, 85 XL2000, and maximum revenue is 1875. And that's it. We just solved a real-world manufacturing optimization problem using linear programming in Python. Thank you.